Form 2 work as tested in the year 2023, Kenya Certificate of Secondary Education, KCSE, Chemistry, Paper 1. Welcome. The very first question from Form 2 work was question number 1. Topic being atomic structure and the periodic table. The atomic numbers of nitrogen and fluorine are 7 and 9. So here we take note that the electronic configuration of nitrogen is 2,5 and that of fluorine is 2,7. Moving to formation of bonds, we realize both nitrogen and fluorine are non-metals. Every atom of nitrogen needs 3 electrons to be stable, and every atom of fluorine needs 1 electron to be stable. For this reason, both elements would form covalent bonds with each other. So for part A, we are asked to draw electron dot and cross diagrams to illustrate bonding in the molecules of nitrogen and that of fluorine. So here, as we've just discussed, nitrogen would form covalent bonds with the other nitrogen atom. So because each needs 3 electrons to be stable, each will also contribute 3 electrons towards the formation of the covalent bond. If we let crosses to be the electrons of the atom on the right hand side, we shall contribute 3 toward the formation of the covalent bond, and the other 2 will remain unbonded. For the atom on the left, if we let dots to represent its electrons, we shall also have 3 being contributed towards the formation of the covalent bond, and then 2 would remain unbonded. So this becomes now the dot and cross diagram representing bonding in nitrogen molecule N2 for the first mark. Moving on to fluorine, the same thing happens. 2 atoms bond together using covalent bond. Now if we let crosses to represent electrons of the atom on the right, we shall contribute 1 electron towards formation of the bond, and the other 6 would remain unbonded. Remember, each atom had 7 electrons on the outermost shell. For the atom on the left, if we let crosses to be its electrons, 1 would be used for bonding and the other 6 would remain unbonded. So this now becomes the dot and cross diagram to represent bonding in fluoride molecule F2 for the next mark. Moving on to question number 1, part B, we are asked that with reference to the diagrams that we've just drawn up here, we were to state why fluorine is usually more reactive than nitrogen for the next mark. So we take note that the diagrams above may be simplified as follows. For nitrogen, we shall have triple bonds. Nitrogen-nitrogen triple covalent bonds. While for fluorine, it is just single covalent bond, as shown by these simplified representations. So that would form the basis of our answer here, and therefore the candidates were expected to inform the examiner that nitrogen has a triple bond, while fluorine has a single bond. So we know that single bond is weaker than the triple bond, and therefore easier to break as compared to the triple bond. So this is the reason that makes fluorine to be more reactive than fluorine. For 1 mark, so nitrogen having a triple bond, half mark, and fluorine having a single bond, the next half mark. Total 1 for question 1, part B. So we now move on to the next question borrowed from Form 2 work, and this is question number 2, topic being salts, but this question required a little understanding of the topic the mole as well from Form 3 syllabus. In question number 2, the examiner tells us that classification of types of salts includes normal and acid salts. The first part of the question demanded that we give the name of another type of salt. So here there is double salts that has not been mentioned by the examiner, but there is also the other option of talking about basic salts. Any of these for that 1 mark. Then part B needed a candidate to have some little information about the mole in Form 3, because we were asked to describe how acid salt can be prepared using 0.1 molar sulfuric 6 acid and 0.1 molar sodium hydroxide. So here we realize that sulfuric acid is actually dibasic. For every molecule of it, we have 2 hydrogens, while sodium hydroxide, every mole will only have 1 mole of the hydroxyl ion. So that means that if we react equal volumes of the 2, then the number of hydrogen ions contributed by this acid would be more than the number of the hydroxyl ions from the alkali, and therefore we shall have acid salt being prepared. So the answer here was we were supposed to mix, or rather react, and the marking point here was equal volumes of the 0.1 molar sulfuric 6 acid that was applied and the 0.1 molar sodium hydroxide. We have explained that this is a dibasic acid, so in solution the number of hydrogen ions would be more than the number of hydroxyl ions. So after the reaction is complete, the salt would still have excess hydrogens, making it acid salt. So equal volumes, 1 mark. Part 2 expected the candidate to go ahead and write the equation for the formation of the acid salt, and this would be sulfuric 6 acid aqueous reacting with sodium hydroxide, again aqueous. We form an acid salt that is called sodium hydrogen sulfate. Aqueous, of course, this is a neutralization reaction, so the other product becomes water. Balanced for 1 mark. Next question from Form 2 was question number 15. Topic is carbon and some of its compounds. But the question also demanded just a little bit of understanding of organic chemistry 1, again of Form 3. Carbon 4 oxide and methane gas. This is an organic gas that we shall discuss in Form 3. So we are told these are gases that are found in the atmosphere. For Part A, state one disadvantage of carbon 4 oxide in the atmosphere. Now, carbon 4 oxide causes what is commonly referred to as global warming. This we can replace with carbon 4 oxide causes what we call greenhouse effect for that 1 mark. Then for Part 2, we were asked now to name one source of emissions of methane. And this is why I said this question needed a bit of information about organic chemistry. We learn sources of alkanes, methane being one of the alkanes. So here, there is a lot of sources. We have production of natural gas that emits methane into the atmosphere. There is also production of fossil fuels. This is also one of the emitting factors of methane. There is mining of coal. Mining of coal is also one of them. There is also decomposition of manure or biogas. Then we also have, on a lesser extent, excretion of mammals. This also releases methane into the atmosphere. For the last part of question 15, candidates were asked to state how emissions of carbon dioxide into the atmosphere can be reduced. And this would include reduction of use of fossil fuels. By the way, this has been a global discussion in the last few months. Then, on the same note, we would also have reduction of burning of wood and even charcoal. Then we also have things like tree planting. There is also scrubbing using alkali. Then we also have green energy that is the world is paying attention to. And this green energy would include things like using electric vehicles to replace those that use fossil fuels. We also have reduction in the number of greenhouses, and there is also the embracing of solar energy. All these would contribute to reduction in emission of carbon dioxide into the atmosphere. And now we proceed to question number 18. Question 18 was borrowed from the topic of chemical families, particularly the alkaline earth metals. Small pieces of beryllium, magnesium, and calcium metals were placed in test tubes containing cold distilled water that was mixed with some indicator, phenolphthalein. So that has been shown in figure 5 below. So we have beryllium here, magnesium, and calcium. Now, in the alkaline earth metal family, reactivity usually increases down the group. So we expect calcium to be the most reactive and beryllium to be the least. So the examiner asks the candidates to state and explain the observations that were made in each of the following test tubes. So in test tube 1, beryllium, we have agreed, is the least reactive of the three. So there will be no reaction. Beryllium doesn't react with cold water. And on the indicator, the solution would remain colorless. Solution remains colorless. So this is half for the observation, and the explanation would be that beryllium does not react with cold water. For the next half mark, moving on to test tube 2, where we now have magnesium, we expect now some bubbles, very tiny ones, and again on the indicator, the solution would be pink this time because we are using phenolphthalein. This is due to formation of an alkaline solution. So we will see tiny bubbles or pink color forms after some time. That observation would be half mark, and then we go ahead and explain that magnesium reacts slowly. Magnesium reacts very slowly with cold water, and of course we are forming magnesium hydroxide, which is alkaline, and that is what makes our solution to turn pink in presence of the indicator. Lastly, for test tube 3, where we put in calcium, this time round the reaction will be more vigorous because calcium is the most reactive of all. So here we shall also see bubbles, but this time there'll be many, and because of the many bubbles we can even use the word effervescence, and again solution would still turn pink because of the formation of the alkaline solution. Any of these observations, half mark. Explanation: calcium reacts vigorously. Calcium reacts vigorously with cold water. For the next half mark. And this leads us to the next question, question number 19. Topic is effects of an electric current on substances. A laboratory assistant wanted to investigate the effects of an electric current on substances. We are told that figure 6 below here shows the arrangement of apparatus that were used. So in A, we had hexane being tested here. In B, we have mercury being tested, and in C, we had aqueous sulfuric 6 acid. There is some mistake in the printing, sulfuric 6, not 4. Now, in the questioning, we are asked to explain why for part A, in A here, the bulb did not light up and no electrolysis took place. So the reason for this is that hexane, as we know, is a non-electrolyte. It is a non-electrolyte because it has no mobile ions. By the way, hexane is molecular. So there would be no conduction of electricity and no electrolysis would take place. Non-electrolyte half, lack of mobile ions half, 1 mark. We proceed to part B of question 19. So in part B, we are told to explain why the bulb lit in B, but no electrolysis took place. Remember, in setup B, the electrolyte that we used was mercury, or the substance that was being tested was mercury. So here, the bulb would actually light because mercury is a metal. Instead of saying mercury is a metal, we could also explain that mercury is a good conductor of electricity, or that mercury has delocalized electrons for the first half mark. Then, why electrolysis did not take place? We would say that mercury cannot be decomposed. Mercury cannot be decomposed since it is an element. Remember, electrolysis only takes place when we use compounds that can be decomposed. So this would earn ourselves the next half mark, making a total of 1 for B. Moving to C. In C, don't forget our electrolyte, or the substance that we were testing, was aqueous sulfuric 6 acid. So here, the bulb lit and electrolysis took place. So we are asked to explain why. Why the bulb lit is because aqueous sulfuric 6 acid is an electrolyte. For the first half mark, hence it contains mobile ions which conducts an electric current, and in the process the electrolyte is decomposed. For the next half mark, giving us a total of 1 for that section. Dear candidates, we are now moving to the last question that was borrowed from Form 2 work, and that is question number 24. The topic tested in question number 24 is structure and bonding once again. Study the structures of substance L and M shown in figure 8 and complete table 4 by giving the names that describe the types of structure and bonding in each. So here, L seems to be the structure of giant ionic substance. You remember sodium chloride that was discussed in Form 2? Yes. And then of course M is diamond. So let us now complete the table by indicating the type of structure and bonding for our structures L and M as we end the video. So as agreed, the structure L actually represents giant ionic structure. For the bonding, it's either ionic or we also call it electrovalent bond. For M, this is diamond. Structure is giant covalent giant covalent, which can also be called giant atomic or giant molecular. And the bond is obviously covalent. This is 2 marks, so each is half. And with that, we've come to the end of our video, where we have taken you through Form 2 chemistry content that was tested in the year 2023, Chemistry Paper 1. Kindly continue to be with the Kenyan teacher and expect more of such reviews.